got a presentation now. I think, Jiri, is this your first time speaking?
Actually, second time.
Second time.
Many years back.
Ah, okay. Well, welcome back. We're glad to have you. Presentation on JPEG XS and NDI. Take it away, please.
Hello, good morning, everybody. How are you doing today? Perfect, perfect. Anybody jet-lagged like myself? Today I'm going to talk about using JPEG XS and NDI for low latency cloud production. The presentation is kind of a technology preview, still a work in progress, but we already have some numbers to show and some information. Okay, how do I? Oh. Okay, thank you. So, I mean, the broadcast production is not really easily accessible to everyone to produce and stream any event, mostly because it's costly, and sometimes, very often, I mean, even the individual products are not readily available for everybody to just pick up and start using. Though it's changing a bit, as, I mean, especially the equipment and compute becoming more affordable. We can maybe take a little bit distant analogy from the film industry, where entire films can be shot on cell phones, like, I mean, this particular case, example, Life is But a Dream. It's a Korean movie shot entirely on iPhone 13. And also how for the equipment to become and the technology become more available are definitely the rental services, where you can have hardware devices, broadcast professional hardware devices on OpEx basis. You can rent them, you can rent the service itself. But still, I mean, you probably would need quite complex infrastructure to deliver the service in a broadcast quality. So I think that the software in a cloud or software and a cloud is kind of helping to bridge the gap and democratize the broadcast production, so it will become available even for small or niche sports, niche events that today or before couldn't be produced in broadcast quality. So on the other hand, the cloud can be pretty expensive. And there are examples of companies or products that were built on top of the cloud infrastructure, like, for example, Basecamp, which is a project management tool, quite popular. And they are moving away from the cloud today because of the cloud cost. I believe that they said that they would save like 50% of their infrastructure cost, which is probably over $1 million per year, if they move back on-prem from AWS, or I don't know what cloud they use. However, it's not the case for everybody, or not the case for each type of service. There are cases where cloud actually makes a lot of sense. And for example, the Basecamp is a 24/7 service that has steady growth, so they can predict the load, while maybe live production is not that case, and therefore the cloud can be much better. And definitely, if you think of investing your money into buying the equipment versus renting few hours in a cloud where you probably pay a few tens of the dollars for the instances and software licenses, it kind of makes sense. Also, with the cloud, it allows you to produce the channels or the sports events in distant regions where you don't have your infrastructure. So again, I mean, instead of building an infrastructure in remote location, you just rent the cloud service for a few hours or a few days, and off you go. But producing the video in a cloud actually comes with a few challenges. The obvious one is the latency and the bandwidth, where transporting the video to cloud and from the cloud takes some time, and in order for the operators to actively work with the live feed, the latency has to be really low. Also, there is a trade-off between video quality and the compute you pay in the cloud. But probably one of the not so obvious obstacles when moving to cloud is the fact that all of a sudden next to the broadcast engineers, you also need a whole bunch of DevOps engineers who understand the networks, who understand the security, who understand the Docker containers and orchestration, which you probably didn't need it much when you were working with SDI or coaxial cables. So what I'd like to focus today is on how to transport the video to the cloud with, hopefully low latency, using TR07 and using NDI in a cloud. NDI became pretty popular for cloud production as a mezzanine format or mezzanine codec that you can use within your cloud infrastructure, within your cloud cluster, to interconnect all the individual pieces of the software with the video. So for this experiment, what we did is we took a AJA Bridge Live encoder that was taking SDI feed 1080p 5994, encoding into TR07 and streaming that feed to a cloud instance where on the edge of the cloud we used Comprimato live transcoder to receive those TR07 feeds and transcode them into the NDI. Just if you're interested in AWS, we use G4D N2X large instance with 8 CPU threads and 1 NVIDIA T4 GPU. And Bridge Live itself is a 1 rack unit standard software-based encoder and decoder that has 4-port 3G SDI device. A little step back just to remind what's the TR07. I assume everybody is pretty familiar with TR07 as that's VSF standard. TR07 is JPEG XS over transport stream where you can think of it really as a successor to original JPEG 2000 TR01 because technology is fairly similar, just TR07 is using JPEG XS instead of the JPEG 2000 codec. The standard specifies 422 10-bit, so it's broadcast quality, and the compression between 1.7 bits per pixel up to 4 bits per pixel, which translates into 200 to 500 megabits for 1080p 5994 streams. The JPEG XS itself is compression technology based on a wavelet. They use 5.3 wavelet transform, which can be 1 or 2 dimensional. And it's intra-frame based codec. The standard JPEG XS compression standards allow up to 16 bits per color component. However, the TR07 is 12-bit or up to 12-bit standard. The codec can be visually lossless at around 3 bits per pixel, and it's capable of mathematically lossless compression as well, but that's not a part of the TR07 standard. And then the NDI, as I mentioned, this is really a mezzanine format that's been used today for live feeds in the cloud, mostly because it's super easy to use. They have quite nice discovery service where you don't work with the IP addresses, you work with the names of the feeds or the services and just pick up the service from the drop-down menu, and it kind of works. It's very low complexity, which is also meaning low compute and pretty low latency. So I think it serves the purpose for the cloud production pretty well. It's also 422 10-bit codec, and for you who are interested in more details, it's the compression technology behind the whole NDI, I think, is called SpeedHQ, which is really very similar to intra-frame MPEG-2. It's basically really MPEG-2 with some different coefficients, as far as I understand. So now to the latency. So what we did is we implemented JPEG XS encoding into the Bridge Live, which is a software, so it wasn't that complicated, and also into live transcoder. And we measured the latency end-to-end from the source of the SDI through the Bridge Live encoding into JPEG XS TR07, up to the NDI handoff in a cloud where we translated or transcoded the JPEG XS from JPEG XS to the NDI. So the end-to-end latency for this leg, which we can really call like ground-to-cloud transport, was about a little bit less than 150 milliseconds, 148 milliseconds. But that doesn't include the transport mechanism like ARQ. We put it away from that because that really differs from or depends on what connection you have, and therefore it can be different for different use cases. You can think of another probably 50 to 100 milliseconds to be added for the transport if you have it secured with something like REST or SRT. And here I wanted to compare the latency to H.264 use case, which we measured with, which resulted in about double of that latency for about 305 milliseconds for basically the same use case, except instead of TR-07, we used the H.264. Here is a little breakdown of, where we actually, or how the individual latencies look like, because the whole workflow is consisted of, you can at least think two steps. One is the encode, and the other one is the transcode. Inside is obviously more because it's encode, it's muxing, then transport, then receiving, demuxing, decoding, and encoding into NDI. But just to give you an idea, the transcode itself on the edge of the cloud from JPEG XS to NDI, it took around 76 milliseconds. And the encode on a source from SDI to the TR-07 was about 72 milliseconds, but that really includes taking the frames from the SDI, encoding into JPEG XS, which is pretty fast. I think it was around 8 milliseconds-ish for encoding, and then muxing into the transport stream, and then sending out. So this is the 72 milliseconds. And similar to the transcode or decode the XS, it involves demuxing, decoding, which is a little bit faster, around 4 to 8 milliseconds, and encoding into NDI. What's probably important to say is that here we worked with 1080p 5994 video, which was encoded at 340 megabits. So the latency is one of the aspects that you actually have to, or really have to consider when you are moving your camera feeds from ground to cloud. The other is the density and the cost, especially in a cloud. How much it will cost you, how many channels you can do per instance. And it really depends on, what you're doing, what exactly you're doing, what codecs you're using, what instances you're using. Here we use the AWS G4DX 2x large, which is a GPU-enabled instance. We use it on purpose so we can compare the performance between the CPU and GPU and give you some insight into, how can GPU actually help with the density and therefore the cost of the cloud production. So we have actually 4 measurements here. JPEG XS on CPU, which is really JPEG XS TR-07, JPEG XS on a GPU, H.264 on a GPU 420, and H.264 422 on a CPU. So if I take it from the top, the JPEG XS on a CPU, we were able to do 2 channels per that instance. That includes the decoding TR-07 and encoding into NDI, which would translate into about $0.34 per channel per hour. We were using that instance was hosted in US East region. Keep in mind that the cost per instance can change and vary between the different regions. And not every region has all the instances available, but this type of instances are more or less everywhere, just the cost could be different. And those $0.3 would translate into something like $274 per channel per month on an instance cost. However, typically you don't run your, sports production 24/7 for a month. Just for illustration, where are we with the instance cost? If we move that decoding, the JPEG XS processing to GPU, we were able to double the density for that particular instance and basically half the cost per channel per hour or per month compared to the CPU. So in this case, it was $0.18 per hour per channel and $137 per channel per month. Compared to, for example, H.264 4.2.0, which gave us even a little bit better density, up to 5 channels per that particular instance, which resulting in a little bit lower per channel per hour cost. And on the other hand, H.264 4.2.2, because this is not accelerated on any CPU and GPU, and it's quite heavy codec, especially compared to things like JPEG XS, we are able to do only 1 channel per that particular instance. Oh yeah, so to conclude my talk today, I wanted to mention that I believe a lot in a cloud. I believe that cloud can really democratize the live production. I think that TR-07 is great technology for transporting the camera feeds from ground to cloud and back. It has pretty low technical requirements, as we could see. It's much faster than H.264 and requires less resources than, for example, H.264. Maybe the bandwidth is a little bit higher compared to, I don't know, JPEG 2000, where the typical bit rates would be probably under the 200 megabits per second for 1080p 60. I think that kind of like de facto standard for broadcast is around 160 to 180 megabits per second for 1080p 60. With JPEG XS, what we're seeing is mostly around 350 megabits per channel. So maybe high throughput JPEG 2000 could help there because it has very, very similar compression capability as the original JPEG 2000. But I think that really cloud can have a pretty big impact on the media industry. It's, in my mind, really efficient for live event production. It allows to use professional broadcast-grade technology for producing niche and small events. Because it minimizes the investment into the technology, into the production equipment. And for the bigger broadcasters, I think, who already have the infrastructure in place, they already have the facilities, I think it simplifies the production, especially in remote locations, remote regions where they don't have any facilities. Thanks so much for your time. I'm happy to take questions. And we are downstairs, booth 45.
Sorry, I didn't bring my glasses with me, so I couldn't see the switch. That's my excuse. Yeah, hi, I'm Mike Coleman from Port9 Labs. I think maybe in a discussion about density, you also need to include a discussion about risk. So the more channels you put on one machine, that machine, if it goes down, you lose more channels. So, I think I'd be interested in knowing what you think about that.
Absolutely, yeah, I totally agree. This is why we choose one of the smallest instances from that family of instances that can support, in the case of XS, two channels on CPU and 4 on GPU. But you can go even one step lower to instance that's more or less half the cost and only 4 CPU cores. Where you would run or probably only 1 channel. And yeah, I totally agree. That makes sense if you run less channels. But in live production, you have to double the capacity anyway if you want to have resiliency.
Yeah, and one other thing I think might be interesting to look at is elasticity, and if you're depending on a certain type of instance, especially GPUs, availability it becomes a factor. Sometimes they're just not around in your, when you need them. So, have you looked at that yet? Like historically, what instances you should use based on, how easy it is to pick one up when you need it?
Yeah, 100% agree. Especially a few years back, it was really pain because even though those instances were listed in the cloud, they might not necessarily be available when you needed them. So, the typical strategy was and still is, you need to book your capacity upfront, right? So typically, and this is why the cost per channel per hour is important, because you need to start those instances maybe even days ahead of your event still. Depending, how high profile or low profile event it is. But typically you book those instances and start those instances days ahead. But recently, I think it's quite improved as the GPU, various kinds of GPU instances has become much more readily available across a whole bunch of cloud providers, not only AWS, which I think was among the first with GPUs, but also Azure or Oracle or Google Cloud. They all have similar type of GPU instances, and the availability is much better.
Hi there. Can you flip back to the slide where you first compare the latency of encode? Is that the
This one or this
one? No, that one. There. So when you compared it to JPEG XF to AVC there, I guess I might have missed it. What format of AVC are you using? Is it the same? Is it intraframe only? Do you allow interframe? Or,
no, it's H.264 without B-frames.
So you're comparing intraframe to intraframe then, the latencies.
Not really. It's not full intraframe, right? You still have, what's it called? B-frames.
Yeah, those are still anchor frames, so but I guess they're not really. I guess the frames would have to be reordered a little bit on that. Okay, because what would be interesting to see, since you're doing that comparison, is what the comparison would be for iframe only AVC as opposed to, because you're really comparing apples and oranges here once you do frame reordering.
Agree and disagree.
I'm just pointing out that comparing two different things like this, once you do frame reordering, of course the latency is going to be longer. So it would be interesting to see what inherently the difference is, because obviously that's one of the advantages of both J2K and JPEG XF is how fast it can encode, but it would be nice to see, compared to a universal codec like AVC, if it was iframe only, what the latency would be on that. And then the second thing is, have you compared the same format of JPEG XS against J2K on this, and what do the latencies look like and the differences between those?
I don't know if I recall the latency numbers for J2K from top of my head, but definitely the implementation we have is not as good as XS. I think the J2K encoding would take maybe 20, 30 milliseconds more.
Because that would make your talk a little bit more complete for those of us that are looking to evaluate things, is getting that understanding. So thanks.
Hi, I'm Adi Rosenberg with Alvalinks. I want to touch base on the transportation or the holes that are missing in the presentation in my mind. You started by saying that you're using SRT to deliver to the cloud, but you didn't provide any information about that, other than saying that you have 148 without ARQ. Can you talk about why did you select SRT? How do you deliver 300 megabits to the cloud by way of SRT? Or why SRT was selected and not just going NDI 5 from the bridge live to the cloud? That is the whole purpose of NDI 5.
So why we didn't use the...
First of all, let's start with the SRT.
I'm sorry?
SRT, you said that you are delivering
Yes.
to the cloud via SRT, which is about 300 megabits.
Yeah.
Cost, reliability, delay, latency. Why did you use that? Do you have any numbers to provide?
So why we used SRT over...
Or whatever protocol, other protocols. You said that
Like
you're
REST?
using... No, whatever you selected. If you choose SRT to deliver 300 megabits.
Yes.
What are the challenges in doing that? What is the associated cost? Can you do that over any link, with every link? What is the latency that you choose? Are you doing that 500 milliseconds with SRT? 1 second with SRT? What is the delay of SRT going to the cloud? This is question number one.
Okay, so SRT would add another 50 to 100 milliseconds depending on the
But then you
connection.
don't have an ARQ. You don't have retransmission with 50 milliseconds usually. So, no, that was the number 148 last to basically till the end, but so 50 milliseconds without any retransmission, so you had a perfect connection to the cloud.
Yeah,
like
I mean,
AWS direct link or something like that?
If you decide to use codec like a JPEG XS, you have to count on the fact that you need to have a good connection to the cloud anyway, even if you are using SRT or REST or whatever other transport mechanism.
So I'm not talking about REST, I'm just talking, you said that you're using SRT, so you're saying that the SRT overall delay was 50 milliseconds, and it was easy to provide 300 megabit upload capability, reliable long-term delivery with SRT.
Yes.
Yes, okay. So next question, why do you use even SRT? Because we have NDI 5, which was published a long time ago, a year ago and beyond, which is specifically catered to do that, meaning that from the bridge live, you can deliver NDI 5 as a native NDI in that sense, deliver that to the cloud. Why do you need to use SRT for that?
So, I mean, there's a...
Why do you need to, sorry, the translation is useless in my mind.
I mean, there are two reasons. One is that, yeah, I mean, we pick up the feed in SDI, but you can pick up the feed in TR07 already, depending on, I mean, what's the typical source. So here, I mean, to give you a complete example, we used SDI source and encode to show, I mean, what's the encode latency or what's the encode latency in our case. But you might work with a facility that actually is based around JPEG XS, maybe 2110 with JPEG XS, and they would do the translation from XS to ATR07 and stream that to cloud. The other reason is, and I don't know, I mean, what's maybe other people's experience with NDI5 for the contribution use cases is it hasn't been that reliable. I mean, at least that's what we saw with some of our customers, that basically they were dropping of frames. So there are even solutions like NDI over SRT, for example, I saw. I mean, we don't support that, but I saw that, I mean, there are things like that. People using SRT to secure the NDI connection. But I don't have that much of experience with NDI5. I totally understand the point. In theory, it makes total sense.
Basically, the NDI5 gives you that security layer, gives you that native NDI support.
In theory, it should. In theory, it should. Our experience is that, or I mean, what we saw from our customers is that it's not as reliable. So that's one of the reasons why they wouldn't do the NDI natively, but use other transport mechanisms.
So the conclusion that you're saying is that you think NDI5 is unreliable as SRT. Just to understand what you're saying. I mean,
I don't have a direct experience with NDI5. Okay. That's what we heard, okay. And that was the reasoning why, for example, they opted for JPEG XS TR07.
Okay. Now the next question deals with my friend behind. You did not talk about the delivery cost or the transport cost in the cloud itself. You talked about the GPU, the instances, but now you deliver that as NDI to one destination, multiple destinations. There is egress cost for the transport. How much was that? Did you?
It depends if you're actually transporting the feeds back to the ground, because ingress is free,
right? That is in the cloud. I'm talking about the NDI output. When I am outputting something in the cloud, it costs me money. How much does it cost me in that sense? I know that I need to pay for the EC2 instance and whatever I select.
So within the cloud, you don't pay anything for bandwidth inside the cloud. You don't pay for bandwidth to ingress to cloud. You pay for the egress when you send the streams.
You output the NDI to somewhere.
Yeah, I mean,
money, unless you just terminate that.
In a cloud,
if you're doing a test and terminate that locally, yes, it costs you just.
Yeah, in a cloud, you would typically. Okay, sorry. Yeah, in a cloud, you would typically feed those NDIs into your visual mixers and other graphics tools and other production tools that you use in a cloud. And this is the purpose why you are even transporting the video feeds from ground to cloud, right? Because you have your infrastructure there.
Exactly.
So the NDI is used inside the cloud. You don't pay for the bandwidth inside the cloud. You pay if you decide to actually move those streams outside the cloud. And then it really depends on the use case, because you can keep them in a cloud, transcode them to your APRs, feed it into, I don't know how to call it, CloudFront CDN, and then you pay for that bandwidth. So it really depends on, what's beyond the point where you get the feed to the cloud, which was the
that was my question.
point of the presentation.
Do you have numbers for that? And
from top of my head, no, but they have a price list
because
online.
they
so
sometimes amount because of the high bandwidth that you need to use.
Yeah, but also, you're asking about OTT delivery then, or you're asking about downloading the feeds
whatever.
back?
I don't care about that.
We probably shouldn't discuss
Yeah.
prices here.
No,
It's all on our website. You
I
can
know,
read
but
it.
he started the discussion. I'm just
Okay.
First of all, number A, you want to know about pricing for downlink, go talk somewhere else. Number B, we have 2 more people and he's already over time, but I want to get the questions in, so please go ahead.
Great. Hi, Thomas Edwards from
Hey, Thomas.
Amazon Web Services. First of all, thank you so much for doing this experiment on Amazon Web Services. We're always glad to have our customers.
You have quite a good service, I must say, so
Good.
that's why we're using it.
Secondly, some of our top-tier customers have expressed concern about the quality of the NDI SpeedHQ codec at its default bit rate. So, we've been exploring taking it up to like a 200% level, which I guess for 1080p 50 would be in the neighborhood of 250 megabits per second.
Yes.
Have you looked into that? And does that change any of your numbers to go from 100% data rate to 200% data rate on NDI?
You're asking about what we see, if there is a concern about the quality of NDI, or it's quite hard to hear the questions because the...
Oh, sorry. I'm saying, in this experiment, were you only using the NDI SpeedHQ
Yes.
codec at 100% data rate?
Yes.
Okay. I recommend you look at 200% as it does improve the
okay.
PSNR of the SpeedHQ codec.
Okay.
Yeah.
Okay.
Okay.
Thanks.
Hi, a very similar question, or following on from what Thomas just said, I was going to ask about, have you considered, and I'm not sure what your actual application here is, your target tier application, but it's the key question is the end-to-end concatenated compression artifact behavior. And if you're doing quite a high bit rate of JPEG XS combined with maybe multiple concatenated standard NDI compressions, then the end critical thing is your end-to-end concatenated compression accumulation of degradation of picture. So I didn't know whether you'd actually done any end-to-end assessment.
I'd like to answer in more length, but we're out of time. But short answer is no, we haven't looked into that for various reasons. But yeah, that's a valid question. However, we see it with, used in many instances, and apparently it's good enough. Even though, even the NDI people were surprised that, high-end broadcasters would pick up NDI for their in-cloud workflows.
Thank you.
Thank you so much.